Welcome back, everybody. This is our Algebra 2 Quadratic Functions, Lesson number 10, Equations of Circles, Homework Review, Part 3. And so in this video, we're going to be doing a little bit of work with circles, but in case you missed the videos 1 and 2 and technique, make sure to catch those as well too. And if you find this video really helpful, I really appreciate a like and subscribe to the channel to know when videos are added to the channel. All right, really appreciate that too. Okay. Question number 5. Circles are described below in the coordinates of their center C and one point on their circumference A. Determine the equation for each circle in the center radius form. So we're going to be using the distance formula, and our distance formula, which we learned way back in geometry, d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And we will call, in this case, A x2, y2, and our center x1, y1. Now, why do we do this for? Well, the distance from any point on the circle to the center is the measure of the radius, and we need that. So for A, let's see now, our distance, or really we'll call R. Let's call it R, because it really is the measure of the radius here, will be 11 minus 5 squared plus y2 is going to be 10 minus y1 2 squared. So our R value is going to be the square root of 6 squared plus 8 squared, the square root of 36 plus 64, sorry, my numbers look small, square root of 100. Now, we don't need to simplify this, mainly because of the fact that because our equation of circle is x minus h squared plus y minus k squared equals r squared. I need a little more space here, so let me push this down a little bit, so, okay. And so here, again, we're using our formula, x minus h squared plus y minus k squared equals r squared. So the square root of r squared is 100, so r squared equals 100. And our h value is going to be 5, and our k value is 2, because that's the y and x and y value of our center. So we plug into our formula, we'll get x minus 5 squared plus y minus 2 squared is equal to 100, and that's our equation of the circle in center radius form. So the first step was to find the measure of the radius, and we'll square that to find r squared, and then take our center, in this case, for h and k, to fill into our formula. So let's do part B. Again, we'll label our x1, y1, and x2, y2. And so r is equal to 3 minus neg2 squared plus neg 17 minus neg 5 squared. And that's going to give us the square root of 3 minus neg 2 is going to be 5 squared. Neg 17 minus negative 5 is the same as neg 17 plus positive 5, which will mean we'll get plus negative 12 squared. So r equals the square root of in this case, 5 squared is 25, and neg 12 times neg 12 is positive 144. So r is equal to the square root of 169. Now, it's a perfect square, but we don't need to simplify because the fact that r squared will be 169. So we don't have to worry about having to simplify the radical, because in the equation, we're just going to plug into find r squared. So in radical form, just squaring it takes care of the radical. So in this case, yeah. So in this case, our form r squared will take care of the radical, and we'll just have the number underneath the radicand. Now we also know, based upon our center, our h value is -2, and our k value is -5. All right, so we plug into our formula, and I'm gonna need a little more space for this one too, so I'm gonna bring this down a little bit. I'll make this full screen, ladies and gentlemen, so everyone can see everything afterwards. So we're gonna plug into our formula. We have x minus -2 squared plus y minus -5 squared equals 169. Okay, because it's r squared. And so we have as our final formula x plus 2 squared plus y plus 5 squared equals 169. And that's the equation of our circle in center radius form. Okay? And again, you notice that the center is -2 comma -5, but inside the equation, x plus 2 squared and y plus 5. So again, we'll see that our h and k values, when we represent inside the parenthesis, will be the opposite number we have there for x and y. And finally, we're going to find the radius of this circle for C. Move up a little bit here. Plenty of room now. So this x1, y1 is x2, y2. Our r value equals the square root of 5 minus -2 squared plus -1 minus -5 squared. Now, I switched it around. It could be, in this case, I could write this -2 minus 5, and then -5 minus -1. It's, in the end, when you square, the sign doesn't matter. So if you switch them around, this is one of those formulas a little bit forgiving in putting the numbers in of the order for x1, x2, and y1, y2. Just can't mix x and y's. So we got, in this case, 5 minus -2 is going to be positive 7 squared, and -1 minus -5 is the same as -1 plus 5, or plus 4 squared. And we're going to get, in this case, the square root of 49 plus 16. So r is equal to 49 plus 16 is equal to 65. Square of 65, which is not a perfect square, but it's okay because r square we're looking for is going to be just a radicand, 65. And that's what we're going to use. So again, we plug in our h and k values, so x minus h. So x minus 5, again with our center, that's what we're using here, x minus 5 squared plus y minus -1 squared equals 65. And so we'll clean up the y minus -1, so we'll have x minus 5 squared plus y plus 1 squared equals 65. Okay, and this is going to be our equation of this circle, whose center is 5, -1, and we found in this case the radius is square root of 65. Okay, and there you go. So here in this video, we use a distance formula to find the measure of the radius. So really, d is really the r value, and once you square this, we really don't have to worry about having to simplify the radical. Okay, which is kind of nice. All right, ladies and gentlemen, this is the end of our Algebra 2 quadratic functions lesson number 10, equation circles, part 3 for the homework review. Again, if you like this video, please give it a like. If you found it helpful, leave any questions or comments in the comment section below. Look forward to seeing you in the next video. Take care and be safe.